We have seen evaluation of postfix expression using stack. Let's see conversion of infix expression to postfix expression. Like evaluation of postfix expression, conversion from one notation to another notation is also stack based. Here we need two strings, one for input and one for output. And there is also stack that holds the operators that are yet to add it to the output string. Here is very simple infix to postfix conversion example 3 plus 4. This is our input. While reading this input, if you get operand, just add that directly to the output. So here this 3 is the operand, so add that 3 to the output. After adding this 3 to the output, this is our input string. This plus is the operator, so add this into the stack. After adding this plus to the stack, now our input is 4. This 4 is an operand, so add this 4 directly to this output string. After adding that 4 to output string, input is empty. We completed reading of our input expression. After reading entire expression, pop leftover tokens from the stack and add them to the output. So plus will be added to this output string and now stack is empty. In this case, only one plus operator is there, so final output will be this string. From the above example, we can observe these two rules. All the numbers are pushed to output when they read. After completion of reading the entire expression, pop all operators off from the stack and add them to the output. Let's see complete algorithm for infix to postfix conversion. This algorithm does not implement composite functions. Function with variable number of arguments and unary operators. Means here assumption is all operators are binary. While reading infix expression, if there are tokens, any one of the following steps can be performed. We have already seen in the above example, if the token is operand, add it directly to output. If the token is operator, post that into stack. After reading last token from input string, add leftover tokens on the stack to the output. If you take more complex infix expression, it has parentheses and functions. Here functions means, for example, trigonometric functions like sine and cos. If input token is a function, push it onto the stack. Suppose if you have more operators with different precedence, if it is an operator, suppose assume the operator we are currently reading it as O1. If any operator already on top of the stack having higher or same precedence than this O1, then pop the higher precedence operator O2 and add that O2 to output. Repeat the same thing until if you have operator in stack which are having higher or equal precedence than currently reading token O1. Suppose if token is left parenthesis, then directly push that into the stack. If the token is right parenthesis, until you get the left parenthesis, pop tokens and place them onto output. While popping all those operators from the stack, if you get the left parenthesis, pop that left parenthesis and do not add that to output queue. Simply discard it. This last case we have already seen. After reading entire input, if there are any leftover tokens present in the stack, pop all the tokens and place them onto output. Let's see one more example. This is our input. Here first token is A, which is operand, so add directly it to the output. After adding A to our output, now this is our input. Now next token is operator. We need to check if is there any higher precedence operator on top of the stack. Here stack is empty, so add plus operator to stack. This plus operator is pushed onto stack. So this is our input. B is operand, so add it to output. Here we have A and B in our output string. Now this is our input. Here next token is operator again. Assume it as operator O1. We need to check any operator O2 which has higher precedence on top of the stack, that has higher precedence than this O1. Here plus operator precedence is 1, which is not greater than or equal to this O1 precedence. So we no need to add this to output queue. Add this O1 to stack. Here next token is C, which is operand, so directly add it to output. After adding this C to output. This is our input. Next token is minus. Assume it as O1. Here we have other operator O2. Its precedence is 2, which is greater than this O1. So before pushing this operator O1 onto stack, we need to pop this operator O2 from stack and add that to output. So it will be popped and it will be added to output. Then at the top, this plus operator will be there. This plus is also having the same priority as O1. So pop this plus operator from stack and add that to output. These two operators are added to output. Now stack is empty. We can push this operator O1 into stack. Here this D is the operand. Add it directly to the output. Here reading this entire input is completed. Then pop all leftover tokens from the stack and add them to the output. Here we have only one operator within the stack. So this minus will be added to output. For this infix expression, after conversion, this is the postfix expression. This is complete program for infix to postfix conversion. Here we are taking character array to use it as stack. Initially top is at -1, means stack is empty. Let's see these two functions first. Here we are adding one function get priority. It will return priority of operator. Here addition and subtraction operators has same priority. So this function will return for both of them 1. Multiplication and division also has same priority but has higher priority than this addition and subtraction. So this get priority function will return 2. For all other operators, this function will return 0. This is our function infix underscore postfix. It has one parameter character array infix expression as input. We need to check each character in input string. If it is alphanumeric value, means it is operand, then add that to output. Here I am not taking another character array to hold postfix expression. Simply I am adding that to output buffer. If character is left parenthesis, push it onto the stack. If character is right parenthesis, pop all operands and add them to output until you find left parenthesis. Don't add this left parenthesis to output, just ignore it. Suppose if character is operator, you need to check if there are any higher precedence or equal precedence operators on top of the stack. Suppose if present, then pop the higher precedence operator from the stack and add that to the output. Repeat the same thing until you find lower precedence operator on top of the stack. When you find the lower precedence operator on top of the stack, this while loop will exit. Then add the operator O1. Here O1 means current operator. We read from infix expression. Add that to the stack. So push that onto the stack. After exiting this for loop means we completed reading the infix expression. After completion of reading entire infix expression, pop all leftover operators from stack, add them to the output. Here I am keeping same push and pop function while implementing stack with array. But notice here this parameter is of type character instead of int. Here pop return type is also character. If stack is underflow, instead of returning 0 as like in previous example, we should return character. So here I am returning single space within single quotes. Means this is the character. If we execute this program, here we need to enter infix expression as input. Here I am entering 3 plus 4 star 2 by 1 minus 5. Then its equivalent postfix expression is this one.